Page 770, number 11. We're to use the 8 rectangles shown in this graph to approximate the area of the region below the graph, and the function that is there, the parabola, is governed by the quadratic equation f of x equals 10 minus x squared. And we're looking over the interval of -1 to 3 on the x-axis, and you can see that's where the rectangles are created. So what we are going to do is we're going to find the area of each individual rectangle, how wide they are, and how tall they are, and then we're going to add them all together. And then I'm also going to show you how to use a Riemann sum with summation notation to find the area, which is a little faster. Okay, so the first thing we need to do, I like to label each rectangle. So we'll call this one 1, 2, 3, 4, 5, 6, 7, and 8. Because I'm going to make a table of values, and it's just a lot easier if you have the rectangles labeled. Keep everything straight. So this is my rectangle. This is going to be the width of each rectangle. And this is going to be the height column. And then finally, the last one is the area column. Okay, so I can just number these now. So I have 1 through 8, 1, 2, 3, 4, 5, 6, 7, 8. Now it's nice to note that looking at the x-axis, that each rectangle, there are 2 per unit. So the width of each rectangle is a half. So I'm going to put 0.5 here for each of these. For each width. And when we're finding area under the curve, we always use same width rectangles. And you'll see why in a minute when I do this using a Riemann sum. So these are all half a unit wide. Now the height is where you can look where each rectangle meets the y-axis. So they're different heights. So when I was estimating these as best as I could, the first one seems to have a height of 9 units. The next one seems to go almost up to, put it at 10. Same with the next one at 10. The next one is, well actually that one's a little taller. I'm going to call it 10.5. And then we're back at 10. And then at 9. And then at 8. And then at 7. Then 6. And then finally the last one looks like it's about 4 units high. So now finding the area is just a matter of multiplying these two numbers together. So we're going to take half of 9 and we get 4.5. Then we're going to take half of 10 and we're going to get 5. We're going to take half of 10.5 and we get 5.25. Half of 10 again is going to be 5. Half of 9, we already did that one, is 4.5. Half of 8 is 4. Half of 7 is 3.5. Half of 6 is 3. And then half of 4 is 2. So now what we're going to do is we're going to add these up. And when we add these values up, I get a grand total of 32.75 square units. Okay, now, unfortunately, that's not completely accurate. If I were to use a Riemann sum, which uses the function value, I'm going to have summation notation where each of my units starting from 1 to 8, that tells me I'm using a counter of I this time. I start at the first rectangle, I go to 8 rectangles. I'm going to take the value of the function, because that'll be the height of each rectangle. Because if you notice, every one of those rectangles hits the function at some value. Here, 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 and so on and so on. And that's the height of each rectangle. So if I just substitute whatever x value they're at into the equation, it gives me the height of the rectangle. And then my change in x, as we know, is a half. So this value is 0.5. And when I do that, I get these values for the area. And you can see that they're almost exactly the same. So I'm going to get 9 plus 9.75 plus 10 plus 9.75 plus 9 plus 7.75 plus, I'm going to wrap around here, plus 6 plus 3.5. Those are my 8 heights of my rectangles. And this is going to be multiplied by my change in x, which is still 0.5. So when I do that, I get an exact answer, which turns out to be 32.5 units squared. Which you can see we're very close by estimating, but it's much more efficient and accurate to do it using the function value.